Hello everyone, Mike Levin, June 10th, 2022, Friday. And I thought I'd answer a question today that I get actually in various forms all the time. This time it was Lyra Yay, again, correct me if I'm getting the pronunciation wrong, but I advocate Linux, Python, Vim, and Git so frequently people are like, what about tool X? What about language Y? And the answer is always yes, use what works for you. I advocate these four things. Well, I'll answer as I read the question. I'll read it, and then I'll start driving, which keeps me honest so that I don't have to keep reshooting this because I'm unhappy with my answer. It's one take, Mike, really. Mike, so this is what I am currently doing. WSL install Linux on Windows 10. Into learning Vim, into learning C. Yes, all of the above, yes. I watched an old video of yours where you explained why you chose the stuff you chose for the short stack, and that you think C wasn't a good idea for more casual programmers and more for professional programmers. But of course I know Python is also widely used professionally. In your old video, you were just speaking about the learning process being easier for Python. So I thought, since I am a software developer apprentice, C should be a good idea for my personal short stack, since it also teaches me about stuff like pointers, a bit about computer architecture, etc. What do you think? Well, I already answered in the comments section of YouTube, so video over. No, not really. I figured I'd answer again in this format, so since it'll reach a lot more people, and I obviously and always have plenty to say on these issues. I'll get my one cheat sheet ready, which I may glance at while I drive, because I'm on a kick where I'm trying to credit the correct people. In this case, it's Martin Richards of Cambridge University. Bet you thought I was going to say Dennis Ritchie, right? Well, Martin Richards in 1967 in the UK created a programming language called BCPL. The Basic Combined Programming Language, BCPL. That's the last. I'll look at that for a while because I wanted to remember that. Basic Combined Programming Language, BCPL. People think that the C programming language, which Dennis Ritchie created side by side with Ken Thompson, okay? So if you don't get the picture yet, the 1960s, Fernando Corbato, after being frustrated by the elites, created time sharing so that he could get access to the hotsy-totsy few in number computers of the day. That was Multics. Multics got taken over by large corporate interests led by AT&T, Bell Labs, and also members of it included General Electric, Honeywell, you know, companies you hardly even hear about or think. I said General Electric. You know, you hardly even think about as computer companies these days, but that's because back in those days it was supercomputers, mini computers. They took up rooms of buildings, and you know, was not what we're familiar with today, but still they needed operating systems and stuff, so they were interested in using this time-sharing operating system from Fernando Corbato called Multics, and the panic over that led to Unix, and Unix was created by Ken Thompson at Bell Labs, hand in hand with Dennis Ritchie, who was working on the C programming language in order to enable Unix to be created. So a lot of people think that the C programming language was the follow-on to a programming language called B. It was not. It was a follow-on to BCPL. BCPL had subsequently had a lot torn out and stripped down and turned into another programming language called B. But the thing that did the innovations was BCPL. And this is long before there was a C. It was 1967, and it was long before when C came into existence, fragmented into all these different things we know today. So C has become a lot of things, and that's going to be part of answering Lyra's question, because, you know, what do I think about using C? My first question out of my mouth is which one. I told her which ones I thought were good from a foundational standpoint in the posted response, but I'm going to answer it again here. So, Java gets a lot of credit for the concept of the virtual machine. The JVM, the Java Runtime Engine, JRE, what have you, whatever acronym you want to put on it. Java from Sun Microsystems, from James Gosling, was really hyped up because, you know, you only had to write your software for the Java virtual machine, and the Java virtual machine was ported to different hardware, and then your Java programs, without being recompiled or anything, just ran on those virtual machines elsewhere. So that concept was innovated with BCPL. It was not Java that brought that to the world. BCPL had the exact same concept of a precompile to a pseudocode. You'll hear all different terms, O code, P code. It doesn't matter. It's just not fully compiled for the hardware. Once it gets down to compiled for the hardware, it's hardwired for that hardware. If you keep it one step shy of that with some common machine language, a smaller set of instructions than the hardware is really capable of handling, but that smaller set of instructions is common to the virtual machines of different implementations, now your stuff is more portable. That's what BCPL was for. That's what that guy, whose name I really shouldn't look up, had created. But we need to credit where credit is due. That was Martin Richards from University of Cambridge in 1967, BCPL. So a lot of things started to be created on BCPL, including my beloved Amiga. They created other, you know, what do you do with one operating system? You create it's a programming language. What do you do with one programming language? You create an operating system. So they created TriOps, which kind of evolved into the preemptive, awesome multitasking without a net, because the Amiga crashed a lot, right? The Amiga crashed a lot because of TriOps, because of BCPL. So I'm just a few degrees removed from the action. I was a user, and I worked for Commodore, the company who used, and I knew Commodore developers who explained this to me back in the day. They're like, oh yes, Amiga-DOS came from an operating system called TriOps that was written in BCPL. Mike Sins, I owe you a lot. So shout out to Mike Sins. He really educated me. He was a quality assurance. He was Commodore CATS, application technical support, not QA. I'm sorry, I didn't mean to insult you. The QA was another guy who needs some insulting, but the CATS team who supported the applications that Commodore put out, one of them is this operating system guy. He went on to work on some secret code at Microsoft. He's a heavy hitter in the area, and he was kind enough to explain all this stuff to me. So I kind of have a recollection of it without all my Instapaper articles that I have collected over the years. But BCPL was not enough to fully implement Unix. So Dennis Ritchie, working with Ken Thompson, created the C programming language, a souped up version of BCPL. Does that mean the C programming language actually does these virtual machine portability like tricks? Yes! C itself was like Java before Java. So Java didn't so much innovate the virtual machine, maybe getting the compile out of the process, but the recompile, an initial compile is always required. Java might have gotten rid of, like, oh, here's the source code, recompile it now, for the other hardware. Just the Java files themselves in their P code or whatever format could flow from one hardware architecture to another. So there was some JVM, virtual machine innovation, but not nearly as much as Java is given credit for. So that portability from C. And that portability is what they were going for in the Unix operating system. They wanted it to be a portable operating system. So, C was the programming language of Unix. Unix became very, very popular, and so C ended up being the programming language of many other things, drivers, other programming languages. So, you know, from the 70s on forward, for some reason, C became elevated in people's minds almost as if it were one of the grandparent languages of tech, which it's not. C came in like the 70s and afterwards. You go back to the 50s and you have things like Lisp, and maybe it's the 60s, but Lisp and COBOL and Fortran and even Algol you could put in this category are probably the 4 programming languages that you would credit as being the grandparents, and not the granddaddies, not the granddads, because COBOL was written by a woman. These are the grandparents of all the modern programming languages. So where did things like BCPL and C come from if they weren't the first of their kind? Well, probably Algol, procedural language. I should probably do a newer video on this. I think I've done this all in the past. But Algol 60, I think, it didn't have the curly braces. So the curly braces were introduced somewhere around this point. If you're ever wondering where those curly braces came from, well, yeah, probably BCPL is where they were introduced. It was for the compiler. There were a lot of compromises for the compiler. And I'm gonna stop at Wendy's again. I'm doing my errand, reward myself. I don't eat at Wendy's all the time, but when I do, I get their new hot, spicy mustard chicken sandwich. So BCPL, yeah. So the tricks. BCPL was itself easily ported to other hardware platforms. So you could create compilers for the BCPL language easily in other languages because of all the tricks it used, all the virtual machine type tricks. They were setting the stage, you see, for portability. Now, it got a lot of the tricks right, but it wasn't complete, so C was created. C became a P in the pool of tech, as if one of the grandparent languages of tech. And then C schismed into a lot of different branches. C++ for object-oriented, Objective-C for different object-oriented, but Apple's purest version, because C++ was a little bit jury-rigged for Steve Jobs' tastes. Java itself is a schism on C. Yeah, hi there. I'll have the number 12 medium, please.
Number 12 medium, what drink?
I'll have orange soda, please.
What?
Orange?
Orange soda?
Yes, please.
Alright, anything else for you?
No, that's all.
Alright, it's 1176 around the second window.
Thank you. So you can think of C as one of the, seminal languages, one of the foundational ones that is okay to focus on and learn. Everything is built from C these days. It's very, very rare. There you go, thanks. When it's not. I mean, some things conceivably could be written in something. Thank you. Thank you very much.
Thank you. Have a good night.
You too. Lisp, like languages that are actually older than C, couldn't have been written in C, right? Maybe the modern implementations are. I'm going to look into that. But everything modern is written in C because the operating systems, the drivers, it just makes sense. All the popular tool chains, they call them tool chains. So I talk about how Linux is, Linux or Unix is absolutely necessary on your machine in some /y way, in some *nix way, which Windows isn't. In order to be considered a credible development platform because of the GCC compiler toolchain. GNU C compiler. GNU stands for GNU is not Unix. So, self-referential acronyms. There's some geek humor for you in tech. So the main and there's a few other ones, there's Clang and stuff, but honestly, to be considered a serious developer platform, you need to host the GNU C compiler, the GCC compiler. And you can't have your paths breaking everywhere. So your paths have to be somewhat standard, meaning forward slashes and all those, conventional paths that I talked about in that last video on Linux, same paths basically in Unix. So between being able to get that tool chain, apt install, common tools and stuff, and having the stuff you write with it found in the right location relative to each other so things aren't breaking left and right, you need all that in order to be considered a legitimate developer platform of the hardcore style these days. And Windows wasn't, so Windows getting the subsystem for Linux was in large part remaining a credible developer platform. You couldn't very well stay on the Windows platform and be self-respecting before WSL, which is why I'm showing the way. It needs a Pied Piper. It only now, with Windows 11, has become an easy process. So for Lyra, if you haven't installed at least 3 separate things, you're probably still running WSL 1 and not WSL 2, the better, newer, faster version. WSL 2 on Windows 10 would have required you to, install WSL, so that hardly counts as one. But the next one is a patch for the kernel, a Linux kernel or something. And then there's a third thing, but all 3 of those things needed to be downloaded, and one of them has a Microsoft installer to it. And, turning on the hypervisor, of course. Turning on the hypervisor was a command. So 2 commands that you had to run. One command activates WSL, another command activates the hypervisor, and then the third thing is the downloading of a Microsoft installer and running it to patch some Linux kernel thing. You got to be doing all 3 of those if you want the proper new WSL 2 running on your Windows 10. So there's that. Fair warning, double check. And so C has evolved. C has become so important to the world that the standard organizations, the ANSI, American National Standards Institute, ANSI, stepped in and, blessed one version of C. And C is only like 40 commands or something. It's really not a big language. It's a much smaller language than Python. Python is like, 60 megabytes or something now. The original standards for C, there's 2 popular ones. There's C89 and there's C99, and each one is a different standards organization. It started out in America as an AT&T thing, even though BCPL is a British thing, but the C programming language was an American thing. So the American Standards Committee, ASCI, whatever that stands for, they put their stamp on C89. So to answer your question, from a foundational standpoint, you should at least learn C89, but you should probably now go to the next one, C99. And in case you're wondering, yes, it does stand for 1989 and 1999. So why such old standards? Because you don't need much more than that. All these other schisms of C are bloated for this reason or that. Rust is another one, just trying to do some similar tricks as Java did. Java was all about memory protection and virtualization. Rust has a few other concerns. I don't even know if I could get it right, but I'm sure it has a lot to do with memory collection. Getting rid of that pointer stuff, right? You have to learn about pointer for computer science. But if you're using a programming language like Rust, it does all the housekeeping for you, but you got your C syntax, you got your curly brackets. So many things use C syntax and curly brackets. It's foundational. It's worth learning. So in my mind, it's really just C89, which is the American standard, or C99, which it came 10 years later, but it's the ISO standard, the International Standards Organization, where the letters in the acronym get reversed because it's Europe. So the ISO standard is C99, and that's probably worth using now because the Linux kernel itself has been upgraded to use C99 just a few months back. I remember reading in the news, it's funny, it's ironic that Linus Torvalds has now announced officially that the Linux kernel is based on the C99 standard. So that's what I would probably recommend for you, Lyra. There's going to be a lot of pitfalls. There's going to be a lot of traps of different flavors of C trying to pull you in. Particularly C++. But if you're not an object-oriented person, you don't need to be using a jury-rigged version of C and poisoning your mind thinking that that's the way all programming is done. There was a long phase where everyone felt that. You know, the heyday of the rise of PCs and 3D gaming engines, when id and Doom and Quake all came onto the scene, Duke Nukem. They were like, how's that done? Oh, it's a compiled C, object-oriented physics engine. Oh, everything's done in C++ now. And there is a big brainwashing. I try, I'm not really a C person because I don't like the housekeeping. I don't like keeping track of pointers and stuff. And then I don't like object-oriented all that much because it's just not how my brain works. I'm a procedural kind of guy. So, I like Python for that reason. C can be used procedurally. C is a procedural language. C is probably, in BCPL before it and all languages like it that are procedural in nature are probably loosely based on Algol 60. You don't want to take up Algol 60. That has no business in a short stack. But C99 has a lot of business in a short stack if you're going to be a professional programmer. You will understand things in a more deep and fundamental way. And, the architecture, the system architectures, because just like you say, these things were built for particular system architectures. It was loosened up a little bit with these virtual machines. I mean, even today, when you look at the high-end compilers, the GCC, free and open source compilers, they have things in them called like LLVM. The VM in there is, again, for the virtual machine. So the really deep and gory hardware implementation stuff is still kind of abstracted away and you're isolated from it, but not nearly so much as it is with Python, right? How far you are abstracted away from the underlying hardware is pretty darn far when you get to a high-level programming language like Python. And it's not compiled, so there's an interpreter there doing a lot of stuff, which is making decisions on the fly. There's still some just-in-time pseudo-compiled stuff in the picture to optimize the Python process, so it's not purely an interpreter. But that kind of stuff is so that certain things remain dynamic, so that you don't have to say how large an array is going to be. Declare the size of an array. You can use a Python list that just grows big and small. And that's popular these days. Abstracting a lot of the hardware implementation details is popular, even among computer sciencey people. But it is probably not the best idea. It's probably a much better idea to adopt C in your short stack. If you find it to be too much work for any given project, then you can use a higher level language or use probably some dialect of C that eases those particular pain points. But on the whole, if you're becoming a professional programmer, an emphatic yes to C. C is the beating heart of so many things. It's probably the only thing out there that's more fundamental to the world than Unix and Linux, than the star Nix languages are now, because those are both written in C. So deeply, deeply fundamental, and not as big and heavyweight as a lot of people make it out. Oh, C, that's such a language. Well, C 89, I think, is 45 commands or something. It's like commands, just like you have commands like ls and cd in navigating an operating system. There's strings like fprint and stuff like that in C, and there's about 40 of them. So it's not a very large language. You can hold it in your mind. The problem is keeping track of memory allocation and releasing memory, because it's very much programming without a net. You have to know your heaps and your stacks and your pointers. And if you don't, things get crashy. Things get very, very crashy. Take it from someone who knows, because all that memory management stuff that makes modern computers so stable, even when a program or application crashes, it does not take down the whole machine, because the operating systems take so much responsibility for isolating process threads. For example, operating systems have these threads that you can try to use for, concurrency. Not a good idea using operating system threads for concurrency. There's a lot of reasons not to do it, but those techniques can keep things isolated from each other, internal in the inner workings of the computer. So if some poorly written C program takes down that thread, it does not take down the whole operating system. That was not true on the Amiga computer, which never went through this cleaning up process that so many C languages had. It went right from BCPL to TRIOPS to having to Amiga DOS or Intuition. I don't know. You guys can correct me. Maybe Dale Luck. Are you out there? J minor. J minor. I'm sorry. J minor is past. RJ Michael and Dale Luck are the two guys, the two Amiga guys who are still out there doing stuff, active on Facebook, whatnot. And they could probably answer these questions more in depth. But at some point, the Amiga's internals were reprogrammed in C. But there's a lot of crashes still. So anyway, yeah, use C for your short stack. Maybe take up Python someday, because Python is often thought of as the glue to glue C components together, because Python comes with a linkable C library. So if you need to take advantage of Python's capabilities, or you need a Python program to take advantage of optimizations you can do in C, the two of them can talk to each other through the C API that the standard Python distribution comes with. It's a wonderful language for people who want the power and optimization and low-level power of C, but also want the power of high-level glue languages. The Alliance was built when Guido van Rossum, the creator of Python, said, "I shall unify sysadmins who want something better than Perl for administrative tasks. And I shall unify C programmers who want to be able to occasionally take shortcuts but don't want to give up the power of C. Python will satisfy both these camps." And that's why Python has become so friggin' popular. But it's not as a requirement, for someone who is going the C route. So you keep on that path, Lyra or Lyra. Please let me know the pronunciation, and do a follow-up question, because I like answering these things. Yay!